In section 4, we've actually split our notes into two parts. So in the first part, we're going to talk about two different methods of factoring. The first one is factoring out a GCF, and then the second one is factoring out a GCF and combining it with factoring a trinomial. So first we're going to talk about what is factoring. So when we are factoring polynomials, we are breaking up the polynomial into simpler terms, which are called the factors. And then these terms, when multiplied together, should equal the original polynomial. So all factoring is doing is finding what did you have to multiply together to get your answer. So it works backwards from multiplication. So our first method is factoring out the GCF. So just kind of review, GCF stands for greatest common factor. So it's usually the first step when you're factoring any polynomial. You want to look to see if there's anything all of the terms have in common, and you want to factor that out first so that maybe you have a much simpler polynomial to factor after that. So let's do some examples. So the first one is 4x minus 2. So what I'm going to do is I'm going to identify my GCF. So I want to know, what do 4x and 2 have in common? And they are both divisible by 2. So when I factor out my GCF, the 2 is going to go in front. And then what I do is I divide every term inside my parentheses by that GCF. So 4x divided by 2 is 2x minus 2 divided by 2 is 1. And then if I were to check my answer, I take 2 and I distribute it back into my parentheses, I get 4x minus 2, which is what I started with. So the GCF doesn't have to be just a number. It can also contain variables. So for our second example, I have 14x squared y squared plus 42xy cubed. So first I look at my numbers. What goes into 14 and 42? And most people would automatically think 7, which it does, but it's not the greatest number that goes in. It's actually going to be 14. Then you move on to your variables. So when you're looking at your variables, you have to take the smallest of the exponents. So my x's, I have an x squared and an x. So the only thing they have in common is 1x, because that's the smaller. Then y squared and y cubed, I can factor out a y squared. So I'll have 14xy squared in front. And then 14 divided by 14 is going to give me 1. X squared divided by x is going to give me x. And then I've taken out both of my y squareds. Plus 42 divided by 14 is going to be 3. I only had one x and I factored it out, so there's no more x's. And then y cubed divided by y squared is y. And that's my final answer. Third example, we have negative 3x to the fourth plus 6x cubed plus 18xy. So first I got my numbers, 3, 6, and 18. Well, 3 goes into all of those. Next, I'm going to look at my variables. So I have an x to the fourth, an x cubed, and an x. So I can only factor out one of those x's. And even though my last term has a y, my other two terms don't. So y can't be part of my GCF. So I have 3x, right? And then negative 3 divided by 3 is going to give me negative 1. X to the 4th divided by x gives me x cubed. 6 divided by 3 is 2. X cubed divided by x is x squared. 18 divided by 3 is 6. And then I've factored out the only x, and I still have my y. There is a second option here, so I could have actually also factored out the negative that was part of my first term. So my GCF could have been negative 3x. And the only way it changes my answer is that all of my signs are now opposite. So both of these are technically correct because I didn't have to factor out the negative that's in front of the first term, but I could have because all of the terms were technically divisible by a negative 1. Last example, we have 8x squared minus 2x. So for my GCF, 8 and 2 are both divisible by 2, and I have an x squared and an x, so my GCF contains x. So I take out my 2x, and I'm left with 4x minus 1 inside my parentheses. One thing to kind of keep track of when you're factoring a GCF is however many terms you started with, you also have to have that many terms inside the parentheses after you factor out the GCF. So most of the examples we did here were 2 terms. They were binomials. So inside my parentheses, after I took out the GCF, I still had to have 2 terms. That third example we did had 3 terms. So after I factored out the GCF, I still had 3 terms inside my parentheses. The second method is we're going to start talking about factoring trinomials. So trinomials is when you have 3 terms. And we're specifically going to be looking at trinomials when a is 1. And we'll also look at trinomials when a is not 1. So trinomial means 3 terms. And then we do have a standard form that they're typically in. And that's ax squared plus bx plus c. We're going to mainly focus on trinomials of degree 2 because that's going to lead us into when we're talking about in Module 4, we're going to talk about quadratics. So we're going to focus on trinomials that are second degree. So there's a lot of different ways that you may have seen factoring in the past. So when I have x squared plus 8x plus 12. So the way that factoring works is that when you break it up into its factors, you are looking for the numbers that multiply to your constant, which in this case is 12, and add to b, which is your x term, which in this case is 8. So one way you can go about this is start listing factors of 12. So the numbers that multiply 12. 1 and 2, 12, 2 and 6, 3 and 4. So of those are all numbers that multiply to 12. But only one of them is going to add to 8. And that's going to be 6 and 2. So when I put it in factored form, it's going to be x plus 2, x plus 6. And it doesn't matter which parenthesis I put the 6 in and which I put the 2. I could have written this as x plus 6, x plus 2. It's the exact same answer, and they are both correct. So our second example, I have x squared minus 10x minus 11. So I'm looking for numbers that multiply to negative 11, but add to negative 10. So the only way to multiply to a negative is to have one positive number and one negative number. So I can have negative 1 and 11, but I also could have 1 and negative 11. So both of those multiply to negative 11. And that is actually the only way to multiply to 11. So I want to know which of these two add to negative 10. And that's going to be 1 and negative 11. So I'm going to have x plus 1 and then x minus 11. And you can always double check that you have factored correctly by distributing back out your answer. So if I want to check this, I have x plus 1 times x minus 11. If I distribute, I get x squared minus 11x, and then plus x minus 11. And when I combine like terms, I get x squared minus 10x minus 11. So that tells me I have picked the correct factors, and I did pick them with the correct signs as well. So just two more examples before we talk about our last method in section 1. So x squared plus 5x minus 6. So I'm looking for numbers that multiply to negative 6. So again, an only way to multiply to a negative is to have one positive and one negative. So I can have negative 1 and 6 or 1 and negative 6. I can also have negative 2 and 3 and 2 and negative 3. So when I'm looking to see which factors it is, I need my numbers to add to a positive 5. And the only way I'm going to add to a positive 5 is if I have negative 1 and 6. So I'm going to have x minus 1, x plus 6. Last example, x squared minus 7x minus 30. So I'm looking for factors of negative 30. So I can have negative 1 and 30, or 1 and negative 30. I can have 2 and negative 15, or negative 2 and 15. I have negative 3 and 10, or 3 and negative 10. And then my last two are going to be 5 and negative 6, or negative 5 and 6. So I'm looking for, of those numbers that multiply to 30, which of them add to negative 7, which is going to be 3 and negative 10. So I'm going to have x plus 3, x minus 10. You are not required to list out all of the possible factors when you are factoring. I do this as like a visual kind of way to help you. If you're not sure of the answers, you can always do this in your head. Like if you know right away, oh, the numbers that multiply to negative 30 but add to negative 7 are 3 and negative 10, you don't have to show me that work of identifying all of the factors. You can just go ahead and do it. So lastly, we're going to talk about combining these two methods. So sometimes you have to combine multiple methods in order to factor a polynomial completely. So in the examples we just did, all of our trinomials, the a was 1. So I didn't have to worry about looking for GCF, because if the number in front of my x squared term is 1, there's definitely no GCF. But if it's not, we want to look for a GCF first, instead of maybe making the problem more complicated than it needs to be. So in our first example here, I have 2x squared plus 28x plus 96. So if I wanted to factor that very large numbers, it could get a little bit more difficult. But if I notice, all of my numbers are divisible by 2. So my first step is going to be to factor out that 2. So then I'm left with x squared plus 14x plus 48. Now I'm going to factor the trinomial inside of my parentheses. So I'm looking for numbers that multiply to 48 but add to 14. And I'm going to go ahead and skip 1 and 48, mainly because 1 in the number is very rarely going to be the answer, especially since I want to add to such a small number like 14. So it is going to be 6 and 8. So I'm going to have 2 and then x plus 6, x plus 8. And that is completely factored. Second example, we have 6m squared plus 12m minus 144. So whenever you're checking for a GCF, always look to see what's in front of your squared term and check to see if that's the GCF. Because 9 times out of 10, it is going to be the GCF. And in this case, all of those numbers are divisible by 6. So I'm going to have 6 and then m squared plus 2m minus 24. So I'm looking for numbers that multiply to negative 24 but add to positive 2. And it is going to be negative 4 and 6. So we'll have m minus 4, m plus 6. It is important that if you factor out a GCF, your final answer, once you've factored what remains inside that parentheses, still contains the GCF in front. Because I want to be able to distribute everything back out and end up with what I started with. And if I don't include my GCF, I'm not going to get what I started with. Next, we have 6n squared plus 72n plus 192. So again, our GCF here is going to be 6. So I have n squared plus 12n plus 32. So I'm looking for numbers that multiply to 32 but add to 12. That's going to be 8 and 4. So I have 6, n plus 8, n plus 4. All right, last example we're going to do from part 1. We have 2x to the 4th plus 22x cubed plus 56x squared. So when we are factoring a GCF out of a trinomial, it doesn't just have to contain a number. It can also contain a variable. So if I look here, all of those numbers are divisible by 2. But another thing is every term also contains a variable x. And I'm actually going to factor out my lowest possible exponent, which is x squared. So I have 2x squared. And then in parentheses, x squared plus 11x plus 28. So now I'm looking for the numbers that multiply to 28 but add to 11. And that's going to be 7 and 4. So I have 2x squared, x plus 7, x plus 4. Let me know if you have any questions about factoring a GCF, factoring a trinomial where a is 1, or combining and having to factor out a GCF from a trinomial and then factor that trinomial.